Hey friends, today we start Module C, which is higher order polynomials. So we're going to look at cubics, quartics, and quintics in this entire module. But first you're like, what did you just say? What's a cubic, quartic, and quintic? That's what we're going to talk about today in 5.1 with polynomial functions. So our goal for today is for you to be able to classify polynomials, and then we're going to look at some more descriptive type stuff with those polynomials later on in the lesson. So the first thing we want to talk about here is standard form of a polynomial. We've talked about standard form for a quadratic, and then we want to go ahead and just make an overarching statement of what is standard form for any polynomial function. So in simplest terms, the standard form for a polynomial goes from the highest power down to the lowest power. So right here in the highlighted text, it says the standard form of a polynomial function arranges the terms by degree in descending numerical order. Again, the easiest way to say that is it goes from the highest powered term to the lowest powered term. So for example, down here at the bottom, you can see here we have 4x cubed plus 3x squared plus 5x and then minus 2. This descended by the powers. So in order for you to be able to classify a polynomial, once you have it in standard form, you have to know the names of which they go by. So every polynomial kind of has a first and a last name, just like we do. And its first name is its degree name. And we know to classify a polynomial by its, I'm going to say, highest degree. So for example, if we used that 4x cubed one from the last example, I can't remember what exactly it was, but something like this, we would look at the highest power and we would say, oh, that's 3, so this must be a cubic. And here are the list of all the powers. So if your highest power is 0, so for example, you don't even have a variable, you just have a number, that is called a constant. And an example of that, like I said, it would just be a number, just like 5. If you have the highest power as 1, that is called a linear. That was what we talked about in Module A. So you would have something like x plus 4. So again, the highest power is 1, so you can see, oh yeah, there is a 1 right there. The next one, if the highest power is 2, that would be a quadratic. That's what we looked at last module. If your highest power is 3, you would have a cubic, 4 is a quartic, and 5 is a quintic. Now, the second name of a polynomial is determined by the number of terms. So how many terms are present in the polynomial? If you only have one term, that's called a monomial. If you have 2 terms, that's a binomial. Again, they went back to one term here. This is a quadratic, but it only has one term, so it's still a monomial. 3 terms would be a trinomial. Again, they went back to binomial. But this is really important down here at the bottom. If you have 4 or more terms, you would just say that's a polynomial of however many terms you have. So on this next slide here, let's put this into action. It says write each polynomial in standard form, and then what is the classification of each polynomial by degree and by the number of terms. So on A, we want to write this in standard form, so I'm going to write my highest powered term first, followed by that 3x, and then plus 5. Again, if you want to put that 1 there, you can, but you really don't need to. So I have this in standard form, so I would say this is a quadratic because I'm looking at the highest power first to determine my first name. The quadratic, and then how many terms do I have? 3. That would be a quadratic trinomial. And that's your final answer. Standard form, first name, second name. Done. On part B, again, we're going to put this in standard form first. So I have x to the 4th power first. And then you'll notice here you have the next term as x squared, but you have 2 of them. So what you need to do is combine them together to say that gives me positive 4x squared, followed by plus 4x and then minus 12. So I've got my equation in standard form. Next, I'm going to look at my highest power, which is 4. So that would be a quartic, 4 quarters in a dollar, 4 quarts in a gallon, quartic. And then I have 4 terms, so this would be a polynomial of 4 terms. And that's all my answer. So if you will, go ahead and pause the video and try A and B down at the bottom on your own. And when you're ready, hit play and you can check your answers. We would say 5x to the 4th plus 3x cubed minus x. And since my highest power is 4, this would be a quartic. I have 3 terms. That tells me it's a trinomial. On part B, I have negative 4x to the 5th plus 2x squared, and then I'm going to combine the 3 and the 10 to give me positive 13. So here I have a quintic trinomial again. Perfect. All right. The second part of today is we need to look at the end behavior of our polynomial. So it says here, when the degree of a polynomial is greater than or equal to 1, there are 4 types of end behavior. So we could look at our graph. So if we were to type this graph into our calculator and graph it, we would notice that both ends are pointing up. So this is a up graph. If we typed this quadratic into our calculator, we would see that it's a parabola facing down, and we've dissected this well last module. So this is an example of down, down. Now, when we get to higher order polynomials, like x cubed, okay, remember we read graphs from left to right. So on the left side, you're pointing down, but on the right side, it's going up. So that's a down, up. And then vice versa. For this graph here, we have negative 0.03x cubed, and it started up as I was approaching from the left, and then it ended down, so that would be an up, down. Now, there is a relationship as to how we know when it's going to be up, up, down, 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 up, or up, down, without even graphing, okay? And we can determine that by looking at our A value. So once we have our polynomial in standard form, we want to look at that first term that we are given, okay? That's called a times x to the n. So that refers to your leading term, okay? That refers to your leading term in your polynomial. So by looking at your leading term, okay, that a value, whether it's positive or negative, makes a difference. Now, what also makes a difference is your exponent. So we're calling that n for the general case. And n plays a role too, whether it's even or whether the exponent is odd. Okay? So think of this chart here like a Punnett square like you did in biology. Okay? So if we have an a value as positive and my exponent is even, that gives me up, up. And that's an example right here. Look at your leading term. Your a value is 1, right? That's a positive 1. And then your exponent is an even number, 4. So that's why it's up, up. Let's look at if your a value is positive, but you have an odd exponent. So a is positive, but you have an odd exponent. That would be down, up. And here's an example right here. Your leading term, your a value is 1, it's positive, but your exponent is an odd number. So you know that your graph is down up. Same thing for if your a value is negative. If your a value is negative but you have an even exponent, you're down, down, and we saw that with a quadratic here. I have a negative a value, but my exponent is even. And then same thing, if your a value is negative, but you have an odd exponent, so a value is negative, but you have an odd exponent, you would be up, down. So let's try putting that into play here on problem number 2. It says, consider the leading term of each polynomial function. What is the end behavior of the graph? And then you can check your answer by graphing it on your calculator. So let's first look at these questions and ask ourselves, is this in standard form? Because in order to determine end behavior, you have to be in standard form first. And on A, we are. So I'm going to look at my leading term, and my a value is positive, and my exponent is an odd number. So let's go back to our chart. If I'm positive and I have an odd exponent, that means I'm going to be down and then up. And we are totally cool if you draw the arrows. If you want to write the words out, that's totally fine too. If you want to get real fancy with it, you could make a sentence saying as the graph approaches negative infinity, the y values go to negative infinity. And as the x values approach positive infinity, the y values are going to positive infinity. That's real fancy, okay? But we're just totally cool with the arrows or the words up, down, up, whatever you need. On part B, again, we notice this equation is in standard form, so I'm good to go. Let's dive right in. My a value is negative, and my exponent is even. So if you need to go back to the chart, you can. But I know that if I'm negative and even, my end behavior is down, down. Okay. Pause the video, see if you can answer this last one on your own. If you need some help, just stay with us. Here we go. Negative 4x cubed, because I know I'm in standard form already. My a value is negative, and my exponent is odd. So if I'm negative and odd, that means I am up and then down. Again, you can check your answer with a calculator, but no calculator is required here. So this would show up on the non-calc portion of the test. Before we dive into turning points, I want to go ahead and take a break. Take a break yourself, and then follow us up with the next video.